Hi, good morning. Today I want to share some of the research that we have done here at STL Partners, thinking about the Edge AI opportunity. If you don't know STL, we're a research and consulting firm. We look at new technology and growth opportunities across telecoms, technology, and digital infrastructure organizations, really focus on the growth opportunities as we see it and have been doing so for the last 20 years or so. And in particular, we have built this practice, this center of excellence over the last 6 or 7 years, looking at the edge computing opportunity and advising organizations and businesses on what the opportunity might be when you look to distribute compute away from just the hyperscale cloud data centers and out closer to where the data is being generated. So we've built up a real bank of expertise looking at this topic area in particular. And what I wanted to do in today's session is 2 quick things. The first is to talk a little bit about definitions and try and define the Edge AI opportunity. And then the second, once we've defined it, will be to try and share with you some of the quantification that we've done to help to back up the very large number that's on the top of the slides. So just to define, first of all, for us at STL Partners, what I'm typically talking about when I'm talking about edge computing is I'm talking about a spectrum of compute which is distributed in between the device on the far extreme and the hyperscale data center on the far right. And it can be a real range of different types of compute locations that we're talking about that sit on that interim in between running compute on an end device like on your mobile phone right the way through to running compute in the cloud. We typically segment into 3 main buckets. So we talk about running compute on-premise. This is mainly relevant for enterprises who might be able to host compute on their site and run some applications on site. We talk about the network edge, which is about hosting compute within telecoms operators' networks. And just to clarify, I'm talking here about compute typically for third-party workloads, so not necessarily the telco cloud stuff that James and the Omdia guys were talking about a moment ago, but using space within the telecoms operators' network to host workloads which are enterprise or consumer-facing. And then lastly, the regional edge, so more sort of smaller carrier-neutral data centers, often in tier 2 or tier 3 markets or cities, as the sort of third type of edge that we typically talk about. And at the highest level, clearly the closer that your compute is to the data, the lower the latency. But also you typically get restricted in terms of the compute capacity that you have. So a device being the extreme example of something which is very responsive, very low latency, but is also significantly restricted in terms of the compute capacity that it has. So this is what I'm going to be looking at, is this kind of spectrum of off-device compute. And one thing that I wanted to kind of make clear here is that when we talk about AI, cloud computing, hyperscale cloud compute, is really good for AI in most circumstances. It's really good because it's really scalable, because it meets a lot of the performance requirements that a lot of AI systems have, and it's already an infrastructure which is mature and exists across almost all markets of the globe today. So that should be acknowledged first of all, and what I want to talk about is some of the circumstances perhaps where cloud compute doesn't work quite so well for specific types of AI systems and specific types of enterprises, and why we think that's the case. So this is a really simple 2x2. You'll see on the y-axis that we're just tracking what are some of the industries that are most aggressively adopting AI technologies. And then on the x-axis, we're looking at industries where we think that cloud-based AI doesn't necessarily meet all the performance requirements that they may have. And just to start to kind of plot some things out, you might put an industry like agriculture down in the bottom left of this diagram. They are typically not fastly adopting new AI technologies. And where they are, the cloud tends to work. They tend to be able to run most AI and data analytics that they may be running on their crops or looking at the performance of their kind of infrastructure or their estates. And it works well in the cloud. So I would fit them sort of bottom left. Professional services, I would put in the upper left box. Obviously, professional services is a wide range of different industries. It could include legal, accounting, consultancy, research, all of these types of things. And typically, these guys are pretty interested in and fairly fast adopting in looking at AI systems. But again, the cloud tends to work really well for them today. They don't tend to be kind of facing major challenges in running AI in the cloud. What gets interesting from an edge perspective is where you start to look at enterprises that fall into the right-hand side of this diagram. And a sort of vertical like healthcare would be a good example of one. Now, I will plot these in the bottom right because healthcare does have some challenges with embracing all cloud-based systems. They do run into issues where they're not necessarily able to put all of their data into the cloud. But equally, healthcare is a kind of a vertical which doesn't necessarily adopt new technologies rapidly. And while there's a lot of discussion and interest in the way that AI might impact healthcare, it's typically not adopting it at a vastly aggressive rate. So I put them sort of bottom right. And then a vertical like manufacturing, I would put top right. So this is a vertical which is aggressively looking at the adoption of AI technologies, and also a vertical where cloud-based does not always meet all of their requirements. And the other caveat to say here is that just because I've plotted these verticals in these quadrants does not mean that all types of AI that they might be running either are or are not met by the cloud. There is always going to be a range, and even within manufacturing, there are certain types of solutions that work really well in the cloud and which manufacturers will look to adopt in that manner. So you can plot lots of other industry verticals on this and start to build a picture of what you see as the main dynamics at play within the enterprise space. And as you might expect, there's a real focus for us in working with the types of enterprises that fit into this sweet spot in the top right-hand corner. That sweet spot of organizations that are looking to fairly aggressively adopt AI technologies across their organization, but don't necessarily find that cloud-based always meets their requirements. And the next question I would expect you guys to ask and to want to know about is, what is it about a cloud-based environment that doesn't necessarily work for these types of enterprises? What do I mean when I say that the performance requirements aren't necessarily met? And really, there are two main things that I mean by that. The first thing is that perhaps a cloud-based environment doesn't meet their requirements because they find that the cloud is too expensive to be worthwhile to run AI systems. And typically we find this where you start to see enterprises that move down the list that I've put on this slide in terms of the types of data that they are feeding into their AI algorithms. So if you are mainly feeding text-based data, text-based prompts into your AI algorithms, then typically it works quite well to run this in the cloud. That's the way that ChatGPT works. And generally, you're not experiencing significant cost. And I mean cost both in terms of your networking costs, so the cost of transporting the data, and then also potentially the cost of moving that data around within cloud environments once it's there, so cloud egress and obviously storage costs. So text-based AI algorithms tend to work quite well in the cloud. As we move down, we start to see more challenges, and particularly at the bottom, AI algorithms that are being fed on video data that are significantly, requiring video footage to be fed in, this is where a cloud-based environment may start to creak and to strain, because you find enterprises that say that it is simply too expensive and also impacts their network infrastructure in terms of running the other applications that they want to run if they are streaming back large amounts of video data to the cloud in order to run their AI algorithms. That's one reason why a cloud-based AI might not meet enterprise requirements. The second reason is when the AI model is being fed on proprietary or sensitive data sets. On the slide, there are a few quotes here from individuals at the European Union and European Council, because this is particularly a conversation that is very relevant within Europe, because the vast majority of the cloud infrastructure that we rely on here is being run by American hyperscalers and may well not be located physically. The data center may well not be located physically within Europe. And so there is a lot of funding and pressure and movement going on within Europe in particular at the moment to try and understand what the implications might be of running AI systems on infrastructure that we do not necessarily have jurisdiction over, and using organizations who may have, who we do not necessarily kind of have influence over. So that's one side of things, is sort of wanting to keep your data within at least the sort of the jurisdiction, the legal sphere of influence of your own country or your own market in the case of Europe. The other side of things is where you've got enterprises that are looking, the data that they want to feed into the models is data that they feel is highly proprietary to them. They feel it might give competitors an advantage if they were able to access that data, and they want to avoid that. And we hear this a lot with certain types of enterprises, and it typically hasn't been a huge influencer on a lot of the sort of consumer-facing AI that folks are starting to use more and more, say like the Gen AI productivity tools, because typically those tools are mainly fed and trained on all of the data that exists in the public domain on the internet already today. So you're not so sensitive about that because it's already public-facing. The expectation is that the next wave of adoption around AI technologies, the next wave of where there's going to be lots more incremental benefit in what AI can do, will be when we start feeding in vast swathes of enterprise data that they hold about the way that their specific organization runs. And once enterprises are starting to do that, there are certain types of enterprises, those ones in that sweet spot that I was showing, that start to get very sensitive about where that data is going to be stored and where they've got to send and transmit that data. So those are the two main reasons why a cloud-based system might not always work for all types of enterprises. And one thing just to flag is that what I haven't mentioned there is latency. So latency used to be almost synonymous with edge infrastructure and with edge computing back in perhaps 2018, 2019, particularly associated with telecoms operators looking to deploy MEC within their networks. We are not seeing latency as a significant driver of edge AI, at least at the moment. And most of the reason behind that is because when you think about the end-to-end latency of an AI system, you have to take into account, yes, the network portion of that, how long it took to transfer the data that was needed for the AI system to, from where it was generated to where it's being processed. But you also need to take into account the length of time it took the AI system itself, the processing time for the AI system, to come up with the recommendation or the answer. And most of the time, what we are seeing is that it's the processing part which is the bigger influencer of the end-to-end latency than the network. And an edge computing location, it does not help to make the processing any faster. You're typically putting compute that you would have run perhaps in the cloud, and you're moving it to a different location. You're not making it more powerful or making it able to get to an answer quicker. What you are doing is, in some cases, you're helping to reduce the network latency, so the time it took for the data to get from where it was generated to where it was processed. And typically, that sort of benefit, that reduction in the network latency, isn't big enough to make a sort of major impact on applications today. So we're not really hearing this one anymore. We're much more focused on, and we're hearing much more about the cost of cloud and the want to try and reduce the bandwidth strain on the latency, and also all sorts of kind of worries around data and data privacy and data sensitivity. So the last thing that I wanted to mention, kind of more on the definitional side, is just that what I said earlier, even industries where I've said this is a real AI sweet spot, they're only likely to leverage edge computing or edge infrastructure in certain circumstances. And that's just because the cloud works really well for a lot of other circumstances. Or even device compute can work very well in other circumstances where you've got perhaps a lighter weight algorithm or model that can run on relatively constrained compute. So there are four main things that I've seen in terms of where genuinely enterprises are looking to leverage edge infrastructure for their AI workloads. The first is a bit of a cheat because it's not actually for running the AI algorithm at all. It's just for doing some of the data pre-processing. So in certain circumstances, an enterprise can collect, perhaps say, video footage data. They can use some pre-processing tools to extract metadata from that video footage so that they can understand, for instance, what is being shown in the footage, but without having to leverage the footage itself. And this is really helpful because it helps across both of those challenges of bandwidth and sort of cost of it, and then also it helps with privacy. So it can help because you no longer necessarily have to, for instance, ship raw data to the cloud that has personally identifiable information about someone as part of the video footage. So this is the first one. It doesn't necessarily even leverage AI at all, but it is fundamental as an enabler to some AI applications. The second thing where I think there is a good reason to leverage edge for your AI workloads is for some types of inferencing, particularly where video is required. And that's because of that strain on the bandwidth and the want to keep down costs. So there is a good reason in some cases to run your inferencing at the edge. Third reason is for model fine-tuning, but only when you're doing that on locally specific data. So what we have heard, for instance, in some verticals, we heard it from a water desalination plant recently, is they have one main model that they leverage to help them to figure out what are the correct mix of chemicals to put into the water to make sure it's clean. But that they actually have to fine-tune that model across all of their plants because there are a number of variables that are very specific to that local plant. So it will be variables like what is the air temperature, what's the water temperature, what's the pH of the water. And all of that needs to be fed into the model, but it really is only relevant to that local plant. And so they do that fine training and updating of the model locally in edge infrastructure while the fundamental foundational model resides and exists in a hyperscale location. And the last one is model training, but only where the data that it's being trained on is highly sensitive. We have just done a significant project looking at federated learning, for instance, which is a means of training AI algorithms on highly sensitive data, where that data, you send the model to the data and train it, and only the updates to the model get shared back, not the raw data itself. And so there are some circumstances in some verticals, like healthcare or defense, where we will see some training of models at the edge as well. And this will be fairly limited, but we do see it as a potential in certain verticals. So there are four main ways. I don't actually have too much time to move on to quantifying. So what I'll do is I'll just share the charts relatively quickly. I'm very happy to have further conversations on this. But we built an Edge AI forecast and published it in January. These are our numbers out to 2030. Now, this forecast is looking at the end-to-end AI solution. So we are including in here revenues from the device, from the compute, from the network, from the application itself, from the integration, from the services. And that partly explains why we think this is a significant opportunity. The infrastructure layer, which may for some be what they would call the edge AI portion, is just one small portion of this overall market size. And what you'll see is that we've looked at the revenue by verticals, and you can see that many of the verticals that come out as most significant, manufacturing, transport, and retail, as the big three, are verticals that were in my edge AI sweet spot when we were looking at the verticals. So you can see what I did there. And typically we see some significant movement, mainly in the transport layer, as we start to see increased vehicle-to-X communications. That's the big one that really changes across our time period. And in terms of use cases, like I was talking about, we see that video use cases are really significant in driving the edge AI opportunity. So computer vision use cases, those are the ones that are labeled CV, looking either at asset monitoring, safety and security, and flow analysis, make up almost 50% of our revenue forecast looking out to 2030. So use cases involving video are some of the most significant ones that we see. So there's plenty more in terms of segmentations and information in the full forecast that we published alongside a couple of research reports that break the opportunity down in more detail. I don't quite have time to go into that now, but I think I wanted to leave with this fundamental message that AI is only going to run at the edge when it's got a really good reason to do so. But we think there is significant enough reasons to do so that the edge AI opportunity will be sizable by the time it gets to 2030. Thank you so much.